Hi, this is Mrs. Bustamante. Today we're going to continue talking about kinetic molecular theory. We're going to talk about how particles move through something. So there are two terms we need to understand in order to do that. The first term we need to understand is diffusion. Okay, so diffusion describes the movement of one material through another. So oftentimes we think about diffusion, it's just going from a high concentration of something. Say you were in a corner of a room and you sprayed perfume. Right around you initially there'd be a really high concentration of those perfume molecules, if you will. And on the other side of the room, there would be less of them because it's further away. So that means it's going to move from this place where you had lots of them, right? If these are all my particles, lots of those particles, and it's going to move over into the empty space. So it's going to move from high to low always. That's how you're going to see things move through diffusion. There's another term in chemistry you need to know. It's called effusion. It's really just diffusion through a container or through something small. Just think about like a hole. So if you have a balloon and you poke a hole in it, you know that it's going to lose its air, right? That air is going to leave the balloon. And oftentimes we talk about this when we talk about Graham's law of effusion. It just tells us that if something has a bigger mass, it's going to have slower movement. It's going to move through something slower than you would think. So here's diffusion, right? This is diffusion before diffusion, right? We have these red particles. They're all close together in a high concentration here, but surrounded by a low concentration relative to themselves. And then after diffusion, you can see that they're all equally spread out. Effusion just is the same thing essentially, except it has to happen through a small space. And in this one, you can see that maybe it doesn't happen as quickly because they're just moving through a small, tiny space. Another thing we need to understand when we start talking about gases is gas pressure. So what is pressure? Pressure is a force per unit area. Gas pressure is the force exerted by a gas per unit area of an object. So gas pressure is the result of a billion and billions of collisions of gas particles with an object. Basically, they're just hitting each other over and over again. A lot of times we talk about atmospheric pressure or air pressure, and this is the result of collisions of air molecules with objects. And so the air pressure at higher altitudes is actually slightly lower than at sea level because the density of the Earth's atmosphere decreases as elevation increases. So sometimes you'll hear they'll talk about atmospheric pressure if you ever go on a plane ride, right? And if there's a change in your cabin pressure, because they actually make it so that the pressure we feel in the airplane is like what we would feel at about ground level because you go so high up. And then a vacuum would just be like empty space. There's no particles, so there's no pressure when we talk about a vacuum in science. There's nothing there. It's just really, really empty space, even though when we think about empty space on Earth, right, kind of looks the same. We can't see those gases there. So you can see these are pictures to show us that pressure increases, right? And by pressure increasing, really we're just having more and more collisions of those particles, right? And one way to have more and more collisions of the particles is to keep the same amount of particles, but kind of shrink the space down, which is something we're going to talk about with gases a lot in this unit, right? Because they have less space to move around. And so when they do that, they tend to collide more, which will cause your pressure to increase. How do we measure pressure? Well, we measure it with a barometer is one way. And 1 atmosphere pressure of a column of a millimeter of mercury, it's 760 millimeters high. And really there's like a well of mercury down here, and you can say that the atmospheric pressure would hit on that well of mercury, right? And it pushes it up the well, and you can measure the atmospheric pressure that way. So there are actually a couple different ways to measure the pressure of something. We can measure it in 760 millimeters of mercury like you see here. We can measure it in atmospheres, and 1 atmosphere is equal to 760 millimeters of mercury. The SI unit for pressure is actually the Pascal, although we don't use it a ton in chemistry all that often. We actually use something called the kilopascal, and we use the kilopascal because 101.3 kilopascals is equal to 1 atmosphere. You might also hear pressure measured in psi's, or pounds per square inch. 14.7 psi's is equal to 1 atmosphere, and mm of Hg refers to millimeters of mercury. 1 millimeter, or 760 millimeters of mercury, is equal to 1 atmosphere. ATM stands for atmosphere. It's typically atmospheric pressure. And a torr, we would say that there are 760 torrs is equal to 760 millimeters of mercury. So you could just say a torr is equal to a millimeter of mercury. Now, I'll probably end up giving you these conversions number-wise, but you should know how to convert between one and another and what is equal to what, which is just dimensional analysis.